Hi everyone, I'm Sifal and in this video I'm sharing my work on whether coherence can help mitigate context window failures in large language models. LLMs struggle with long context inputs, one of the reasons being positional bias. Taking inspiration from Alan Roth's vocabulary constraint task, we identify the gap. The evaluation process, mainly the identification of positional bias, relied on using random words. But language, real language, uses semantically related words, which prompted us to ask, does coherence actually help improve the instruction following capabilities of LLMs? The vocabulary constraint task's goal is to assess how well LLMs deal with the chaos in the input. Mainly, we ask it, given a list of words, to write a story about them. The evaluation is done by checking whether these words are contained in the generated sequence or not. We tested at 50, 200, and 400 rules and used a variety of models. Importantly, how do we actually define coherence? Our approach relies on WordNet hypernyms, which you can think of as a set of words belonging to the same topic. Now, an example of that you can see on the figure on the right, on the first line, is the alternation of randomness and coherence. Let's talk about the results. The most important one is that coherence actually helps. With a little caveat is that some models are much more susceptible to this than others, specifically at a certain number of rules. For example, Mistral AI's model at 200 rules sees a 4.7 times improvement when compared with pure randomness. A good question you might ask is, perhaps this is just due to some unlucky turn of events where random words tended to be longer, which led to the degradation of the results. And we actually did evaluate that, but our results do not show this correlation. Actually, in some cases, we see the opposite effect. Now, we have talked about the relative difference in the results, but how about the absolute results? Do we benefit from increasing the number of rules? Well, actually, our results show a ceiling of 200 rules. If you keep pushing more than that, you get actually diminishing returns. Now, what about positional bias, which was our first point of investigation? How does this interact with that? Now, interestingly, the positional bias still remains, but coherence seems to behave like a bias, literally in the mathematical sense, lifting the curve up. Now, to summarize, coherence actually helps, but it is model and the number of rules specific. Extending beyond a number of rules yields either limiting or diminishing returns or actually negative returns. Positional bias remains. Now, for the future direction, there are many ways about how you can approach this problem. Perhaps, in my view, the most important one is to see whether this actually holds in real applications. There are some low hanging fruits that I have left. The important one is, for now, we are only evaluating in a binary form regarding the effect of positional bias. But we could extend this to a more extensive study. Now, thank you everyone for watching this. And if you want to read the longer version, there's the QR code. Thanks for StartDoc for organizing this event and to Lightning AI for the GPU credits. Thank you, everyone.